Hi, I'm Amanda.
And I'm Alicia.
And today we're going to teach you about
redox reactions.
After watching this video on redox reactions, you will be able to 1. Explain, compare, and contrast the terms oxidation and reduction. 2. Given a chemical equation, you will be able to identify the process as an oxidation-reduction reaction. 3. Given a set of reactants, be able to predict the products and balance a simple redox reaction. And finally, 4. You'll be able to explain and define the role of an oxidizing agent and reducing agent and identify both of these in a chemical equation. Now that you'll know what we'll learn by the end of this video, I guess we should begin by explaining what oxidation and reduction are. A redox reaction occurs when there is a transfer of one or more electrons.
A substance is oxidized during a chemical reaction if it loses electrons. It may be more difficult to recognize which substance is oxidized based on loss and gain of electrons alone in an organic reaction. So it's helpful to look and see if the substance gains electrons or loses hydrogen. That means it was oxidized.
A substance is reduced during a chemical reaction if it gains electrons. In organic molecules, it may be difficult to recognize which substance is actually reduced. It's helpful to look for a loss of oxygen or a gain of hydrogen to tell that it's been reduced.
Remember, a redox reaction involves a transfer of electrons, meaning the total number of electrons remains the same from the beginning to the end of the reaction. This also means the oxidation of a substance involved in the chemical reaction must result in the reduction of the other substance and vice versa. Where one goes, the other always follows.
Now, before we do an example, do you remember how to identify which atom or molecule was oxidized or which one was reduced? If you're having trouble remembering, there's a simple way to help you out. Think oil rig.
Oxidation is loss of electrons. Oil.
Reduction is gain of electrons. Rig. Now that we know what oxidation and reduction are, let's try a real-life example. We're going to do a redox reaction with potassium and chloride. Remember, all atoms or elements that are in reactants that are by themselves have a neutral or no charge. Don't forget to balance your equation. In this reaction, the potassium loses an electron, meaning it's been oxidized. The chloride gains the electron that the potassium lost, meaning it's been reduced. Since there's no additional loss or gain of electrons, the product will have the same charge as the reactants, 0. That is, if you've properly balanced your equation. Everything in the reaction will end up being neutral. Now that we know potassium was oxidized and chloride was reduced, we can determine which substance was the reducing agent and which was the oxidizing agent. Don't worry, this is the easy part. Let's look at potassium first. If potassium was oxidized, it lost an electron. This electron was gained by chloride. Therefore, we call potassium the reducing agent because it reduced chloride. Potassium now has a positive 1 charge, and chloride, with its newly adopted electron, has a negative 1 charge. Do you notice how the total charges still equal 0? Now that we identified potassium as our reducing agent, the chloride must be our oxidizing agent. Chloride causes the oxidation of potassium when it gained potassium's electron. Pretty simple, right? If the atom or molecule is reduced, it's an oxidizing agent. If the atom or molecule is oxidized, it's called the reducing agent.
Let's review. We can use oil rig to determine which substance is oxidized and which is reduced in a chemical reaction. Oxidation is loss of electrons.
Reduction is gain of electrons. We also learned that in a redox reaction, there is never a gain or loss in the net charge, only a transfer of charges. Therefore, the overall charge of the reactants must always equal the overall charge of the products. Finally, we learned how simple it is to identify reducing agents and oxidizing agents. If an atom is reduced, meaning it gains electrons, it's an oxidizing agent.
If an atom is oxidized, meaning it loses electrons, it's a reducing agent. A battery is a great example of a redox reaction that we use every day. Batteries like these convert chemical energy using manganese oxide and zinc electrodes with an alkaline electrolyte like potassium hydroxide. The battery works by oxidizing zinc and reducing manganese oxide. And since redox reactions are reversible, some batteries, like the one in your car, cell phone, or digital camera, are rechargeable. We hope you learned a lot about redox reactions.
Thanks for watching, and when in doubt, think oil rig! Oh, I messed that up.
Focus.